All right, in this video, I'm going to be working free response question 2 from the 2024 CalBC exam. And this one was, yet again, parametric. I kind of thought this was going to be polar, but really in my heart, I kind of thought that last year too, and I was not going to be surprised at all if we got parametric once again. So they're going to give us x prime and y prime, and hopefully you opened the book and saw this and were like, okay, yes, good. I know what to do if it's a parametric free response, because we've practiced this. Maybe not so much in like the past week or two, because we practiced a bunch of polar in my class, but we have done a bunch of these. Speed of the particle at time t equals 2. We got to know our formula. Okay, so speed at t equals 2 is going to be the square root of x prime of 2 squared plus y prime of 2 squared. All right, and so I need to probably plug x prime and y prime into my calculator. So 8t minus t squared, and then negative t plus the square root of t to the power of 1.2 plus 20. Okay, that's interesting. And then you want to, because we've got y3, I'm going to do the square root of y1 squared plus y2 squared. And we're going to see, if we need to use that again for, say, like total distance or something, we'll know that we've got that in y3. Okay, so and so if I want speed at t equals 2 and I programmed speed to be in y3, I'm going to call for, I don't know, graphed. Okay, so if it's graphing and I don't want it to graph, I act like I'm turning it off, quit back to the main menu, calling for y3. I'm going to plug in t equals 2, and I'm going to get 12.305, or you could call that 12.304. Okay, and that's going to be the speed of the particle at time t equals 2. Okay, part B, find the total distance traveled by the particle over the time interval 0 to 2. Show the setup for my calculations. So we're just going to integrate y3, but we are not going to write y3 right there because they don't know what we mean. What we're going to say is x prime of t squared plus y prime of t squared with respect to t, and then we're going to use the calculator to compute this. So I'll call for an integral, math 9, integral from 0 up to 2. I'm going to integrate speed to get total distance, just like if this was a one-dimensional situation. y3 with respect to x, I'm going to let it think, and that's 15.902. Okay, and then c, what's going to happen there? Find the y-coordinate of the position of the object at time t equals 0. Okay, well, they told me the y-coordinate of the position, at time t equals 2. So I know that y of 0 is going to equal y of 2 plus the integral from 2 backwards to 0 of y prime of t dt, which they already defined for me. Okay, I can remind them I know that this is 6 plus that the integral from 2 back to 0 of y prime. And it might be good if I just double checked that y prime was the one I put in y2. It was the one with the square root. So I'm going to take 6 and I'm going to add math 9, integral from 2 to 0 of, let's see, y2 dx, and let it go, and I'll get that equal to negative 1.174 or 173. Okay, and that's part C. We showed the setup for our calculations. We're going to move on to part D, and I think I remember seeing that this one had something a little bit more interesting. Oh, yeah. Between t equals 2 and 8, particle remains in the first quadrant. So I guess that means x is positive and so is y. Find all times t in the interval 2 to 8 When the particle is moving toward the x-axis, give a reason for your answer. Okay, well, toward the x-axis, let's decode that. Okay, I'm in the first quadrant, so there's my y-axis. Okay, that's not very good. I can do better than that. Here's my x-axis, and if the object is moving toward the x-axis generally, okay, that's going to be that y is decreasing. So I need y prime of t less than 0 on the interval 2 to 8. Okay, so what I'm going to do is I'm going to graph y prime of t, and that's y2. I'm going to turn off these, so I don't want to see those anymore. Okay, so I'm going to press enter, turn off that graphing, leave that one on. Don't need to graph the speed. I am going to graph y2 between t equals 2 and t equals 8. And hopefully, you know, the standard window will show me where it's negative. It looks like this is going to be good. Okay, I've got that. And great. Okay, happy. So I'm going to calculate the 0. Okay, it looks like it's about there. Scroll to the left, y is positive. Scroll to the right until y is negative. Okay, so the 0 has to be in there when it went from positive to negative. And that's going to be, all right, so y prime is less than 0. And so I'm going to say y prime less than 0 for 5.222 less than t less than or equal to 8. Okay. Now, if I'm saying y prime is strictly negative, you know, when maybe I should say and right there, that might be better. I mean, I think it means the same thing, but I kind of like this response a little bit better. Okay, so that's my reason is y prime is less than 0, and my interval is 5.222 up to 8. Okay, but again, like whether you include the endpoints or not is not really the type of thing that they're going to be really taking too seriously in AP Calculus. And yeah, I kind of like this one. This is a good one. You know, again, parametric. This time it has something a little bit more interesting. The last couple of years it's been like very much just like, do you know the formulas? But this one, part D, had, you know, you had to think about it a little bit. It was something that we hadn't seen before in the past. So I think that's going to be all for this video. Thanks for watching.